Hello everyone, good morning and welcome to the class. I'm connecting to the cluster. Now let the cluster be ready. Today we'll talk about the volumes and volume claims, persistent volumes and volume claims. and yeah, cluster is ready. If you want to deploy the pod permanently, like if you don't want it, you have to clean up the deployment object. Okay. Right. So let us talk about something called persistent volumes. What are persistent volumes? You remember, right? In the Docker, like we have the concept of volumes where we use them to have backup of our container data. Similar to that, you have something called persistent volumes, and we call them in short as PV. Right, PV is nothing but a persistent volume. It's a directory or where you can have backup of your pod data. Means inside the pod again, it's a container data. So this is the physical storage actually, right? This will be created on the cluster or outside the cluster. Always the best practice is it should reside outside the cluster. So that's a persistent volume. How do you attach this to the pod? We will attach this to the pod through something called persistent volume claim. And this is the hierarchy. That's how they get attached. Means persistent volume will get attached to persistent volume claim. Volume claim in turn will get attached to pod. Why is this hierarchy? It is like to provide a layer of abstraction. Generally, PVs will be taken care by the admin team. Means again, like in certain projects, the cluster creation, maintenance, backup, recovery will be taken care by a separate team called Kubernetes admin team, and the claims would be created by Kubernetes development team. See here, admin team or development team, both are developers, both are DevOps teams, right? You may call them as Kubernetes developers, means who work for deployments of the application, like who write the manifest files, who work for the application configuration and deploying, like working on deployment manifest file, service file, configuring ingress. All of them would be called as Kubernetes dev team. Creating cluster, maintaining the cluster, recovery, backup of the cluster will be taken care by Kubernetes admin team. So initially, Kubernetes admin team, whenever they create the cluster, they'll also create the PVs. It could be external to the cluster. So they'll create the PV. Generally, PVs of different sizes will be created. Then, as per the application requirement, dev team will create PVC. Now, whenever the size of the PVC matches size and the type of the PV, there are different types of PVs like classes. Once they match, it will go and attach to the PV. That's how PVC gets attached to PV. And we'll attach PVC to the pod. That's how finally pod gets attached to the PV. You may ask, why don't we attach this way? Because it's to provide a layer of abstraction, because dev team need not work for creating the PVs, the size of the PVs, the backup of the PVs. All of that dev team will not be looking into. So they don't need to understand what is inside. I mean, what is the underlying PVs, how they were configured. Similarly, admin team need not focus on attaching them to the pod. So to create this layer of abstraction and to get rid of any dependencies across the teams, this is how it was architectured, like PVs and PVC. So initially PV should be there. So whenever a dev team creates the PVC, which matches the size and type, it goes and attached to it. Understood? So let us create a PV. First, let us create it so that it will be more clear, and then I'll take up the questions. Let me create them. If you see kubectl get PV. Okay, there were no PVs. Let us create it. Again, you have a manifest file, like you have the configurations, like API version. See, API version is V1. Kind is persistent volume PV. Some name I have given as PV1. Some storage I have given 1 gips. And persistent reclaim capacity. That's a policy. Like once it is free from a pod, it can be attached to some other pod. And where is it located? Some path on the host, right? Volumes reside on the host. So obviously, some path on the host. So yeah, I am taking the path of MNT data. This should reside on the machine wherever your pod runs. So what is the machine where this pod runs? Where our pod runs on the worker node, right? So it should be on the worker node. Let's go to the worker node. So we have given the path as mount. Data is not there. I'm creating a directory called data. I would also like to place some file, index.html. Okay, this is PV, the physical storage directory where it is. Now, PVC is an object of Kubernetes. Just come here. Let us create a PV. By the way, we did not apply it. Let me create this. kubectl get PV. So you can see here PV1 created and the status is available. It's not attached to any pod. PV is there now. Now let us create a PVC. So API version is V1, kind is persistent volume claim. So persistent volume claim, PVC1 is the name. Read write once. Access mode is read write once. Like it can write to it once. Every pod can write to it once. And the storage is 500 MI. So this size of the PVC should be less than or equal to PV. In our case, it is less actually. And read write modes are same. Like access mode is same. If I create it, it will find some matching PV and gets attached to it. Get PVC, right? Now check the PV. See, it was bound. Earlier, it was available. Now it was status is bound to this PVC because the size of the PVC is less than or equal to the size of the PV. Understood? It got attached. Now the point is PVC got attached to PV. Now you have to attach the pod to this PV. We did not define any class, so it's a default class, manual storage in this case. You have different classes. If you are creating dynamic storage class can be there, you can create them automatically. If you are managing a separate cluster, you can use different things for your storage class. Here, I did not mention storage class means default manual. PV is created and PVC got attached to it. PVC. Now, how do you attach to the pod? Let's go to the deployment manifest file. Like we have configured environment variables, like a config map, secret and all. We'll attach this volume to it. Okay. Let us add it. I am just removing this. If you want, you can leave it. I don't want these variables anymore. Okay, done. So now I would like to attach the volume. So inside the container, you can have some parameter called volume mounts, which are all predefined attributes. And give some name to your volume mount. Let's say I'll give something like data storage. This name is user defined. Okay. And then mount path. So what is the path you want to map inside the container? Isn't it? Like actually, if it is on the um, um, host, it's MNT data, but it should be mapped to some path inside the container, right? And I'm using PHP. So let us say I will use, this is where PHP index.php file is. So that's a mount path, right? So I have mapped it. Then you have to define, okay, I have mapped it, but volumes should be defined here in the same indentation level as containers. So volume mount name I have given as, means I have a data storage. Persistent volume claim. This is how, see, data storage is this one. And this data storage in turn got attached to volume claim. Claim name, which is PVC1. Right? Let me put it diagrammatically. This is the EC2 instance. On the EC2 instance, on the worker node, you have the volume here that should be mapped. This is the pod container. Okay, inside this you have var www.html. Now this path is mapped to this. We have created PV with this directory as storage. We have created PVC with the size and class attached to that PV. Now this was attached to volume mount data storage. Data storage is nothing but this particular path inside the container. Now this PVC got attached to this spot, got attached to this PVC. Understood this configuration, volume mounts for the container, and defining what the data storage is actually. That data storage is going to get attached to this click. Apply -F. Okay, before that, we would need service also to see the new file. So I'll get my service also ready. Let me make it notebook just to test it. 2001. Type is not port. First, creating a service. Something gone wrong. Service port, not port. From that service one. This is in camel case. Apply minus F. Deployment 1.yaml. Okay, they are up and running. How do you check that? Okay, first let me describe the part. See here, you can see the volume. Volume mount name is data storage, right? That's one way you can see, and you can see all the events that get started. Another way is exec minus IT hyphen ls. I want to check the data of this, right? You may exec bin bash and check it, or else you can do this as well. It was not showing anything. Maybe let me just go inside this bin bash. I don't see any data here. Um, oh, I got it. See, I created a file outside this. Okay, now I have the file because I did not have any data. And now do you see that? Right, that's why ls is showing empty earlier. Now, yes, I have the data. This is the one that should be seen on 30,001 of these instances. Perfect. Is this clear? Any questions in this part from anyone? Any questions?
Uh, Pre-
Okay, just give me 1 second. Um, PV. PVC. Yes, these are the PV and PVC files.
yeah, so here where we are mentioning that class to attach the PV to PVC or like to attach PVC to pod with Preethi.
What is a class? I told you class, we did not mention. It's a default class, manual class.
Okay, so even when we create pods, like for example, if we change the replica set or something, how these can get attached to that PV to the pods?
This is your PV, okay? This is PVC. PV is attached, I mean PVC is attached to the PV. Here you don't have anything with the pod or replica. So your pods or replicas are going to get attached from here. This is your template. This template is following all the spec data. Your template means it will create copies of your pods with this particular data. It is replicated. So under the template, we have given the configuration. So every pod will get this replicated, right?
Okay. It will use all these. Okay, even we have defined volumes also, right? So it will use these volumes and it will mount. It will attach.
This is the path inside the container. So
Okay.
this is the path inside the container. Container is created from this image and this port. This is all container data which would be replicated inside every pod. That's what is under template. Pod is getting created with this kind of container. Every replica will have the same.
Okay. Similarly, volumes also, whatever we define, that will mount, right? Whenever the pod got
Volumes
created.
are defined and created only at one place. It could be on the inside the cluster. In our case, it is the same cluster. It could be outside. Volume is your MNT data path, not this one. This is not your volume. This is the volume mount path inside the container. See the diagram. This is the path inside the container. Your volume is this one. This is your volume. This resides outside the cluster generally, or else at least outside the pod. This is on the worker node in our case. It might be anywhere outside the cluster. This is the volume. This is not volume. This is the mount path which has to be mounted to the volume. Mount path will reside inside the container.
Okay. Got it. Got it.
Preethi, can you please explain once again PV to PVC, how we can connect PVC to pod? Which step?
PVC, you will create PV. PV
Yeah.
will be created first. Then you will create PVC. PVC will attach to PV by matching this size and the type of the PV, like whether it is a manual PV or a dynamic PV. In our case, they are all manually created. That's a class, which is a default variable. So PVC size should be less than or equal to PV. Here, PVC size is less than or equal to PV, so it got attached to it.
Uh, but yeah, it is less than 500 MB. This is for 1 GB. How we can attach, how we can communicate with the PV to PVC? Like which step?
When you create,
Both are the same, na? The name.
just a second, give me.
Yeah.
See, this is your PV. This is your PV.
Yeah. Okay.
This is PV. Kind is persistent volume. This is kind is persistent volume type. How can both are same?
No, not both are the
Mhm.
same, but how communicate with the PV to PVC attachment?
PVC will get attached to the PV by matching the size. Like size should be size of the PVC. Let's say you create a size of the PVC as 5 gibbs, right? It will search for some PV. Whenever you create it, it will search for the PV, which is the size is equal or more. And then the class, once they matches, it gets attached. That's the criteria of it getting attached to the PV. Initially, we did not create pod, right? It got attached when immediately whenever you create PVC, you got this status here as bound and the PVC to which it get attached. You don't do anything additionally for PVC to get attached to PV, except the
Okay.
size and the class. Once it matches, it goes and attached. See, that is the reason we have the flexibility, or that's the reason why PV and PVC were made separately. Because, like I told you, whenever admins create the cluster, they'll create many PVs with different sizes, right? And the storage classes. So whenever dev team means Kubernetes development team who are working on application configurations, whenever this is as per your application requirement. So whenever they create a PVC, it will automatically bind to the PV available by matching the storage size and the class. You
That
don't do
means only
anything
for
for
the
it
based
except
on to the
connection.
storage. Based on to the storage only, we can check that PV to PVC connection
Size,
communication.
first the size,
Yeah, storage. Yeah.
size of the.
Mm.
That's why the layer of abstraction. So the dev team need not worry about whether PV is created or not, which to which PV we have to attach. That is not taken care. Means that's not manually, right? Like whenever you create a PV, whenever dev teams create their PVC, it automatically binds to the PV.
Mhm.
So they don't need to do anything for it.
Okay, can you please explain, repeat once again this specification
Which one?
deploy, yeah, deploy specification.
Huh?
Yeah, this
Deploy.
specification. Yeah,
This one, deploy
yeah.
specification, this one. Like inside
Mm.
the container, you have the actual path that's called volume mount, and you give some name to that volume mount. I have given it as data storage and the mount path. Like you define your image name, your ports, volume mounts is another attribute, which is a container attribute. Container volume mounts can be defined as such. And then the whole, okay, you said it's a data storage, but what is this data storage actually? That will be attached to the claim. Claim name is PVC1. Whatever claim you have, you give. Because claim is already attached to the PV. Now pod is getting attached to PVC. So because it got attached, whatever data present in MNT data is now available under var www.html. Ram Prasad, if you want to create another volume on the PV and PVC, you have to replicate these files, give different names. You have this, right? You have to create the same manifest file, give different names, degrees, different specifications, whatever you have. Like PV for SQL, PVC for SQL, whatever. Give different names, different specifications as per your application. Like you created multiple deployment objects, same is the case.
Pretty one small question. So basically, you're saying like whatever slash mnt slash data, whatever the data exists, that will show in slash var www.html in the container, right? You're saying,
Right. That is
but
the basic concept of volumes, right? The
but
same thing. Yes.
but that should not be the case, right? Because all the containers, logs, data, everything that should go to mount data. Because if container got crashed or if container got
Do you
it was
remember one thing? Like volumes are used for data sharing as well, right? It's not only for backup, for data sharing from host to container and container to host. Do you remember that? Suppose
uh,
you have some file and you want to test that over the application. And not only that, like you might be having some files on some folder and you want to test them, or else you want to deploy them in the container, or else there'll be something like a container where you want to quick test some standalone applications. So you can also share the data.
okay, yeah, got it.
I am passing this file from here to HTML path of the container.
Okay, Preet, yeah.
Uh, Preeti, any importance for that access modes which we are seeing? So when we
Yeah,
create,
read write once,
yeah,
read write many. Read write once means like you will be able to read write to one pod at a time. Many means it can read write to many pods. You have those different classes.
yeah. So if we create a PVC with PV, right? So should that access modes also should match, or it won't take into count for that access modes?
Storage class and the size should match.
Okay,
Access
so PV
modes,
can have read write many and PVC can have read write ones.
yeah.
Okay.
Actually, you have different storage, I mean different access modes. Yeah. Even I don't remember like what are all the modes. I can check here. Volume attributes class. Because the whole point is we don't create volumes. Generally, definitely in real time, there'll be a separate team who manage them. We'll not have visibility for the underlying volumes.
Yeah,
So
I understand. Yeah,
we
understand
don't
that. Just
create.
wanted to understand if there is any
Yeah,
connection, right?
that's why what I'm saying is, so it will not be handy or we don't memorize them. You can refer this document so that you can see different access modes. Because we don't generally create, those are not any. See here, they can be mounted read write once, read write only, read write many, read write once pod. See different access modes. You can see here, right? What it does. Use read write once. The volume can be mounted as read write by a
Water.
single node. Please keep muted. Please keep muted. Read write once mode still can allow multiple pods. That's what it can be written to multiple pods kind of. So here are the different definitions for each of those parameters. And like I told you, right, it can be different storage classes. Ours is manual. You can have dynamic storage class connecting it to EBS and so on. You may connect it to Elastic Block Storage on AWS or else on GCP. You have different ways you can do it.
Yeah.
See here,
And yeah,
volume plugins for Azure or else NFS. Maybe admins may know these very well, like how to configure and all. Like I told you, PV is more of a kind of which would be taken care during the cluster creation by admin team. PVC, yes, PVC is what we may be admin team also. Like it's all DevOps, it all under DevOps. So it depends on where you're working. Most of the time, I was into deploying part of creating PVC and pod, but yeah, we work on this thing, like creating our PVC, mapping it to our container path, like where it should be mapped, right? That application data, this is important. So here I would like to bring out one more thing. See, this is the part we'll be focusing on when you are working as Kubernetes developer, right? I'll create a PVC which suits my application as per the path size and all, right? So at this point, you may be thinking, okay, this will be more known by developers, right? Because it's their application, let's say address book or PHPDB. It's developers, they know where is their application data or what should be backed up and all. True, right? That might be like more known by developers. Sometimes developers, they themselves create it, or else there'll be a separate DevOps team who will create it for them. Or else another perspective of it is, like let's say I'm a DevOps person, but I would be deploying some Prometheus or some Grafana, some custom Jenkins. At that point of time, I should configure my containers. It's a DevOps owned configuration, not the dev team owned configuration. Am I making sense?
Yes,
Okay.
yes. It's a custom Jenkins we are
It
creating.
could be anything. That's how even we own that part. Or else if it's an application thing like address book, that part would be owned by dev team, development team, core development team. So those are wide perspectives of it.
Pretty, one more thing. So here you declared that volumes, right? So
Mm.
can we attach different volumes like log for log purpose? We will
Yes,
create
yes.
one PVCs and database we maintain separately.
Multiple volumes can be there. Okay, all those volume mounts should be defined here. Like one volume name is data storage mapping to this one. That's why it's a list. Do you see? Whenever you see a list,
Yeah,
it
yeah.
could be multiple things. So under
Mhm.
volume mounts, the nested list means another let's say DB storage. And that path would be, of course, that would be from another container. But for example, let's say on the same path, you want to collect some logs. So logs, name is logs, path is, let's say, root logs. Then under volumes, again, it's a list. You will define that name here, and again, you will attach to another claim.
Okay. So mount path can be different, should be different, or can be same, right?
Obviously, if it is same, what is the point of creating
Yeah.
another volume mount? Same
Okay.
volume mount, right?
Okay. Mount path is our customization then.
Mount paths or the paths inside the container. So
Yeah.
var www.html is where you want to put some HTML file. I could have another path in the same container. In the same container, I may have something like this. Logs. Okay, I want to attach volume to this also. So I will create volume mount called DB storage. Or okay, let's say logs. And the path is /logs. Right? Again, under volumes, I'll define that name as logs. under which volume claim could be PVC2 or whatever. Got it?
Yeah, got it.
Even
And
it is PVC2 also, that will finally store into /mnt/data, because that is a volume.
no, it is already, see, already that PVC is attached to PV. You have to create one more PV. Means admit,
Oh,
that's why they should create more PVs. Already this PV is bound to PVC. It cannot attach to PVC2.
okay.
When that's why you will be keep on creating application team or dev team, whatever you call them, they'll be keep on creating PVC. Those many PVs should be available. Each PV, it's one-on-one mapping. So they will be having so many PVs created. So your PVC2 will go to PV2. PVC2 will go to PV2.
Got it.
Sometimes if PV is not there, that will be in pending state, hanging state. That's again troubleshooting of your PVC. Here you are seeing status bound, right? It will be in pending. So how do you debug it again? Describe the PV. Any object in the Kubernetes, you can describe it. Describe PVC, PVC1. So here you will see where it is going to bound. See, bind complete. Yes, here you will see the error if it is not there. Right? First, do one thing. Don't create PV and create PVC. Then you will see the status bound, the error you will see. Okay. So that's how you will know it's not available. Also, when you get PV also, you will know it, of course. That's how you troubleshoot PV1. Yeah, when you describe this PV1, you will see, okay, it's a host path, bare host directory volume. Sometimes, like I told you, it could be elastic block storage on AWS, or it could be on GCP cloud, or it could be on-prem. So it will define what type it is and how it is. Okay. Is this clear?
So depends on the whatever the data, for example, logs or any kind of data, we will decide the storage, right, Preethi?
Yeah, the storage is a path inside your container.
Okay. So can we perform the delete operations of the volume when the store, if we don't need any duplicate data, or like if you want to erase the old data?
You can delete the PV, not the data inside. If you want to remove the data, you have to go to this path manually and delete the data. But if you want to delete the volume itself, you can do it.
Okay.
Uh, Ma'am, so we can have nested, means earlier we saw the only volume concept, right? Where we mounted a particular folder over another folder.
Only difference is now you are having another layer in between, which is claim.
Right. So now PV is a storage which is available through PVC. Now if I create folder within PV which I want to have available as a volume, as in not this storage concept, the earlier folder on folder mount concept, so that will be possible, right?
Volumes concept in Docker, that will not be possible in cluster.
Oh, okay.
That is for when you run containers in a standalone mode.
All right, so I mean what I meant was, like, here we are talking about the whole PV is getting channeled through PVC to the pod. Now I'm saying okay, so volume concept itself is from the Docker completely. Okay, so here only the whole volume will be available, that's it, and there is no nesting of it. All the PVs will be individual standalone, and there will be a corresponding PVC for every volume.
Yeah. To get attached to the pod through PVC, get attached.
Okay, and a single PV can be connected to multiple pods. through different PVs.
Through different
Through different PVCs. Sorry, a
See,
single PV.
here you are having a one pod replica. See, don't get confused yourself. Okay, this is the pod. Okay, pod is having this path. This is mapped to this. When you
Yes,
replicate it, just simple, you get the same copy of one more thing. Right? One more pod will be getting attached to the same PVC because it's a following the same template. It gets attached to it. This PVC in turn got attached to the same PV. So every container will see the same data as first replica is seeing. Replica 1, replica 2, all of them will get attached to same PVC. They'll have same data. They're all replicas after all.
right.
Just apply the same logic of your replica. Template means a copy, a blueprint, whatever you call it. That will have container specifications or pod. This is all your pod specification. Which key it should use, which secret it should use, which image it should use, which image pull policy it should use, which port it should use, what are the volume mounts, what are the path. This is all replicated. Replicated meaning pod 1, pod 2, pod 3, pod 4. Okay. Here is a replica count 2. So whatever it is, everything will follow the same. Means every pod will have the same data, means same PV, right? It's getting attached to the, see, this is replicated. And this is using data storage. Data storage is all getting attached to PVC. One means all replicas will get attached to same PVC. That makes sense because everything should have same data. They're all after all replicas. Logical, right?
Right, right, right,
So don't get confused with a lot of things. Just understand the same template. We learn template. What is a template? What is a replica? What is specifications we have learned? We are appending or expanding the specifications. Means all of that should be replicated. That's all. As simple as that.
right. I mean, this one understood, ma'am. But the question I had was related to, I mean, when there is a, I mean, this is a normal use case that mostly there will be uh, microservices. So if there are microservices, not necessarily a particular service will be using one storage. I mean, multiple services can have a shared storage as well as their personal storage. So in such scenarios, when two services are running, they have their own storage as well. Let's say service
Firstly,
one and service two.
hold on, please. Firstly, if it is a microservice, all of them wouldn't follow the same template, right? Why is that getting coming here? If this is a microservice, let's say for PHP, it's a deployment one, and this is following this template. If it is another microservice deployment two, that follows another template, another specifications. Obviously, the data storage, the path, everything is differing, right? How
Okay.
multiple things goes to the same replica, same PVC?
When you mention microservice, another microservice, do you mean a different application altogether, or part of the same application you are mentioning? I mean to say one application which has multiple services.
One application, multiple services, meaning what are the multiple services?
I mean, one is a GUI front end, one is managing database, one is
They
managing.
have different deployment objects, right? Separate deployment objects for each of them.
Okay, okay. So hence the different PV altogether. Okay, okay, fine. Got it. Thank you.
So this is the concept of PVs and PVC. And there is a question from Ram Prasad, what happens to the pods? Pods goes down. Pods goes down, that's all. Your PV, PVC wouldn't be affected. Because a pod is a replica, right? This replica may go down, another replica will come up. Same like it follows the same template. So PVC, PV wouldn't be affected unless you delete them manually. Okay, so now I have explained you the concept with some sample examples, right? Like just PV or PVC, like how they work, how they get attached. This is what we have seen. Similarly, we have learned the concept of deployment, services and all. So now what we'll do is, we'll use all these objects and deploy our PHP DB application, which is a microservice application. So that you will get a clarity on how multiple services work together. Right? Let us see. Let's look into that. Like, point is, we are going to deploy PHP DB application. Address book application is straightforward. Like I deployed PHP image, anything you can just deploy. Let us deploy PHP and DB. From the scratch, we will deploy them by creating all the objects. So can you tell me first, let's pick up PHP. If you want to deploy this, what are the Kubernetes objects you want? Meanwhile, what I'll do is, firstly, okay. So get PV, get PVC. You should not do this. Delete PV, PV1. You should not do this. Rather, you should delete them in the reverse order how they were created. First, PV should be created before PVC so that PVC can search and get attached to it. Then pod should be created and deleted in the reverse order. Delete, deploy, deploy one. Okay, all the pods would be gone. Right, pods are getting terminated. Now, if you check PVC, PV, they'll be still bound because another pod, another replica might come up to get attached. Now, because pod is gone, okay, I can delete the PVC. PVC first, then PV. Otherwise, it will just go into hanging state. It will not allow you. Now, delete PV, sorry, PVC, PVC1. Okay, get PVC, nothing, get PV. Now do you see status is released? It's not bound, right? Means this PV can be attached to another PVC also. Anyhow, I'm deleting it now. Delete PV, PV1. So this is the order in which these objects should be deleted. All right. Now, let's come back to this PHP-DB. How to deploy this PHP? First, let's talk about PHP. What are the objects we need? What are the Kubernetes objects we need to deploy this PHP?
Oh, we need
Objects we need.
deployment file, SVC service object,
We need deployment object.
service object, yeah.
And what
Configs. We also have configs for storing users.
storing users PHP.
Okay.
The front end, the PHP to deploy.
Okay, front end. Yeah, sorry.
We need a deployment, we need a service, and what else? We need a secret to pull the image, private image, right? That's all we need for PHP. So let us deploy this and see. Let us create a manifest file which uses this PHP DB1. Okay. I'm just creating a folder to keep these components separate. I'm creating a manifest file called web.yml. You can put multiple objects in the same one, like deployment object, service object. You can put all of them in the same manifest file, and those objects should be separated by 3 hyphens. That's how you can have it. And the key is a Docker key? Anyway, I'll check my secret. So everything is same. If you see it's a deploy one, I'm just giving the name as deploy one only. Replicas are 2. Okay. And match labels app v1.
Image pulling from Docker Hub or like from okay, Java, my private. Okay.
Docker Hub. And this is the port you have. 32,000. Just a second. Okay. Let me check the secrets. It's a Docker key, which is fine. Also, it's a node port 32,000 when I'm forwarding it to. This is also fine. Let me apply this manifest well. Apply -f web.yml. Okay. So 32,000. Okay, front end is ready. Obviously, because we need to deploy the service object. So now, sorry, deployment object. Sorry, DB service. We need to deploy DB service. So what are all the objects we need for this DB?
DB deploy. Yeah,
We need deployment.
we don't need service, right? We can attach.
You definitely need a service for them to communicate, but this can be of type cluster IP. Without service, they wouldn't communicate. Here it will be node port or load balancer.
Okay.
Deployment service, and it can use the same secret for pulling the images. So the
Config maps we can use here.
and then we can use config map to pass some database name, secret for DB password,
And even volumes also, right? That was to store the data.
persistent volumes, persistent volume claims. So these are all the objects we need for DB deployment. Here it is 3, 4, 5, 6, 7, 8, 9, almost 9 objects for the entire application. So let's get creating. First, let's create a secret, volumes, volume claim, and so on. Secret for password. Actually, for in our case, secret is already configured at the image level, right? I mean, the password is configured at the image level, but yes, we can also see how it works. So please keep muted everyone unless you are talking. Please keep muted everyone. And also please lower your hands. If you have any question, raise your hand, because when you raise your hand, it pops up, the window pops up. I have to focus there. Please lower your hands and keep muted everyone. So this is your secret name and this is the password. This is the user, I mean, this is the key and this is the value. All right, I want to set it as a password only. I am expecting you all might have completed your hands-on on the secrets by now. I'm not using any encrypted value. I'm directly using decrypted. If you want, you can give encrypted value also. So let me create the secret. Okay. So secret is created. Okay, this is your secret. Secret is created. Then what else we need? Deployment object we need, service object will create it towards the end. First, let's create a PV for it. PV, whatever manifest file we have created, we can use the same, or else let me create a new one. pv.yml. The same manifest file. So persistent volume v1, MySQL 1, storage class manual. Actually, that's a default one. And this time I'm giving this path inside the worker node, right? This is the worker node. I'm giving the path as home EC2 user.
MySQL.
We need not create it. It can have the backup if we don't create it. So I'm just leaving this as the one where it will have backup. Now let's create PVC before creating it. Right, volume claim, PVC, storage class, size, this is all I have. Same manifest file. Let us create PV first. Always this is how it should be. First PV should be created. Get PV. So PV is attached. Sorry, it's available. Now, okay. So bound MySQL 1. Right? Status is bound, that gets attached to MySQL 1. Now deployment object, and then we'll map this PVC. I'm creating a manifest file dp.yml where I would like to create both the deployment and service.
Where do we define the DB user, Preethi?
Which DB user?
Database username and password. Password, that is fine, store in the secret.
Hmm.
What about the username? Basically we'll do in config maps, right?
Deployed this in the Docker as well. We deployed this with the Docker Compose. Did we create user? If we don't create user, we are using root user, right? We did not create user at that point also. Only we are creating root password. If you want create, yes, you can create user. But that should be done at the image level itself.
Okay, image level, yeah.
Or else maybe you can check if any environment variables are there for that image so that you can create a users with environment variables. If that is there, yes, then you can use config map. If that's not there, you have to create at the image level by running some SQL queries. I think environment variable is there. Anyway, first let's look into this. So my volumes, right? This is user defined name and the claim name. This is the claim name. First, I have defined the volumes, whatever it is. Okay. Inside the container, right? MySQL root password. That's a variable name. Sorry, environment variable name. And also key name is the same. I have given the same key name as well. So the key name, the value password will be assigned to this variable. And then volume mounts. This is user defined and this is the path which has to be backed up. If you have deployed this through the containers through Compose, you will be very much comfortable with this configuration. Anyhow, this is the path where the container data, actual data is stored. The name I have given is MySQL store. That is mapped to the claim called MySQL PVC. And the service. Service is of type cluster IP. So type can be cluster IP. Cluster IP none means no port. If you don't define the type means it will go to cluster IP type only. That's the default type. So any questions in this configuration, just look into this part and let me know. Can I apply this?
So the value for key is password, right? Preethi, we have defined MySQL root password is, the value is password, right? We have set.
Right.
Okay, yeah, yeah.
This is the, sorry. This is the secret. Okay, this is the key inside the secret. The value password will be sent. And the volume's name is, it's attached to MySQL PVC. So we need to check MySQL PVC is attached to MySQL. It's in perfect state. This is the path. It should get attached to, of course, SQL1 folder should be created. So let me apply this. Apply -f db.yml. It shows deployment service are created. Get deploy. Get deploy. Deployment 1, deployment 2. Deployment 2 is still getting ready. Okay, let it be. Pods are okay, all of them are ready. Now get PV. Anyway, we don't see anything here. You can see the PVC name. PVC got attached. Pods. If you want to see all the details of this, describe pod. I want this pod name. Okay, so varlib MySQL from SQL store got attached. Image was pulled successfully. Okay, fine. Come here. This is where we expected volume. Perfect, right? See? Okay, backup is ready. Now, let's store the data. Perfect. Right? Okay, good. All of them were stored in this pod. You have the data backup. If you want, you can see exec -19. SH, I believe. MySQL, we are using default user, root user. Password is set to password. And all of this coming from image. Database name, all of them set. If you want, you can set here also. So let's start from EMP table. Table, all of them got created, all the three. Perfect, right? This
So,
is how you can.
so does this data stored in /varlib SQL folder also in the container?
Obviously, right? That's what we have mapped.
Okay, can you go to that path once in container? Yeah.
I did not go here because we have done all of this checking in the Docker Compose. With Docker Compose, we did this already.
Okay.
We did this all this testing manually, means running containers and standalone as well as with the Compose. We did this, but anyhow, this is the path that's factor. Sorry.
Ma'am, can we attach? Attach a volume while pod is running as well, right?
No, you cannot. You have to have it either it in standalone mode also not possible, here also not possible. You have to attach when it is before creating it. Say I'm deleting this pod. Obviously, another pod comes up because we were deploying it in the deployment object. See, in 11 seconds, another pod came up. You will have the data backup. your pod will have all the previous data also, which we have seen in the containers with the compose.
So in case of changes to the volume, all the replicas will redeploy, as in, yeah, reboot, as in created again, right?
Just a second.
Yes, okay.
Perfect. Tell me now, in case of, come again, please.
Yes, yes. So, if we want to make any changes as per the volume configuration,
Mm.
so all the replicas will uh, be redeployed.
It depends on what configuration you're making, what change you're making, whether it is redeployed or whether it is reapplied. You mean
No,
this
I mean,
part?
so
Want to remove
paths paths can be created while running different paths.
different path created means this path, you mean?
Yes, yes.
Not during running anything. You should put this configuration and create your pod. You cannot apply or create the volume mounts later on. How do you apply it during runtime? Already pod is there. You did not create it. How do you create them later on? How do you apply them? How do you attach it to the PVC? All of this should be done before your pod is created, not during runtime.
Okay, means and it will. I mean, to apply to the all the pods will be restarting, as in when we make the changes and while running we make the changes, but it will not replicate immediately. We save this, and then all the replicas will be redeployed, and
Yes.
then only the
Mm.
changes will be applicable.
Yes.
Okay.
Try it out when you are doing hands-on, like you may be having many questions as such, right? Try it out when you are doing hands-on. That will be more clear because you observe what is happening. That will be very much clear for you. You can also try. So this is how we deployed the PHP DB app using all these components. For us, it almost took 9 objects. We created 9 objects, right? 2 deployment objects, 2 service objects, 2 secrets, one for pulling the image and one for DB storage, 4, 6, 7, 8, 9. Total, we have created 9 objects. Till now, we have learned them separately, right? We just learned the concept. Okay, what is a PV? What is PVC and all? This is a practical implementation of how they can be used. Like for an application, for a microservice application like this is how you create it. So this is an end-to-end example which shows you like how you deploy your application in the cluster using all the objects we learned. Till now, from the beginning, we have learned this separately, right? Like we learned deployment, then service, then we learned different types of services. Here you can see which one should be of node port and which one should be of cluster IP. Let me also show you that. Get service. Right? This is the SQL service. It's of cluster IP. You can't access it outside. This is for PHP, which is of node port, right? So, like depending on the requirement, you will choose which type of service to use. Ideally, this should be load balancer. Of course, ideally, this should be of cluster IP and you can put it on ingress, right? You can do that. We have already learned ingress. You can also implement ingress for this and forward this to some path. So this is how it is. Let me also do it if I can see something. Ingress.yml. I think it was outside. Let me place it on service one. Service one on root. I'm just leaving it as it is. Let me see what happens. I can make it a cluster IP type. ing.yml. First, let's see the rules. Describe ing. On the root service one, we have these pods. Let me check if it got attached properly. Get pods with the output wide. 71, 72, it is good. And then what else we have to check? Get service in this namespace. Ingress Nginx. Okay, you can see here 30,062. Let us hit this on 30,062. 30,062. Put it on HTTPS. Perfect. Do you see that? Right?
Using Ingress path-based, we are able to, but now it's not notepod, right, Preethi?
Which is not notebook.
This we have used Ingress now, right?
This one 30,062. That is notebook only.
But we have used Ingress, right?
Ingress is a service that can be of any type. Generally, it should be load balancer type. We created it as a notebook because of limitations with the cluster.
Okay, yeah.
Got it clear, everyone? Even record was stored successfully. I have placed ingress also. So total, how many objects for our PHP DB deployment? I'll include ingress also.
It's 10.
10 objects we have created. I'm asking this number for a reason, which will be continued in the next class. But is this much clear for everyone? This is a complete end-to-end example. Please do the hands-on. If you are thorough deploying this simple application, it looks simple with the 2 services. If you are thorough with it, this is enough. It could be any number of applications. It could be 10 or 20. The same concept follows. Which services should be cluster IP? Which services should be node port? How is your ingress routing the traffic? How is a secret used? Config map used? Deployment object, service object, PVs, PVCs, all of them in practical. You can connect the dots here. Till now, I have explained with a sample example. Yesterday, we did an example for secret with a sample example password, and we have used it just like an environment variable with no purpose. But now we are setting the environment variable with the secret, which has a purpose, right? We have set the root password with this. So execute this hands-on. This is mandatory. It gives you an end-to-end scenario. Do the hands-on for sure. Without hands-on, just listening and just if you are trying to clarify everything, if you are trying to master 100% in the class, that will not be enough. Unless you do the hands-on, you can't master 100%. We are talking about this one, like you may use it for, like, go to README, check the environment variables. If you want to set a username, a different user, see, this is what we did, right? With the secret. This is done at the image level itself. If you want, you can do it with a config map. Am I making sense?
Yes. That is my same question. Yeah.
Database can be set, different users can be set, but it depends on image. Need not necessarily every image support all these environment variables. This image is made as such, so you have to go to, the whole point is you have to go to readme of the image, understand what all it supports. So in this case, yes, all of them can be created with secrets or config maps as per the a particular variable. Root password with a secret, database name with a config map. Again, empty password with a secret in the Kubernetes cluster. So try out these things if you want. And we have also taken the backup with the volumes where libmysql is taken as a backup. We did this with the Docker standalone. We did with the Compose. Now we are doing with Kubernetes. All of that clarity you should have. What is done with the Docker? What is done with the Compose? What is done with the Kubernetes? What are the differences? You should gain expertise on all of these concepts so that you can answer any sort of interview questions and work in any kind of projects. Know the concept thoroughly. Your real-time scenarios, your real applications would follow the same concepts. The way you use them, these won't change. Your platform, your environments, your applications will change. That's all. The how you deploy, the way you are deploying, all of them remain same. The concept of how you use environment variables, where you should go and understand, all of these remain same. So gain the concept thoroughly. That will help you. So that is all from my end. Actually, another thing is there which I need to cover today, stateful sets. Anyway, we'll cover that tomorrow and we'll get into some other interesting concept tomorrow. A very advanced part. We'll take up that tomorrow. Any more questions from this class? From anyone?
Preethi, I have one question, but this is not related to this class. So if
Please.
anybody, yeah, if no one has any questions, I can raise.
Yeah, go on, please.
So actually, for me, actually in the real time, I just working on one task, Preethi. I just need some inputs. So basically, we thought of to, we have a, small microservice called AGL. We got this AGL from product, but we are planning to customize that AGL service using this Jenkins pipeline through script and everything. We are planning to customize. So the initial step was already we have a image for this AGL from product. We have stored in ECR. So from ECR, the image is there. So my manager gave that image from ECR. What he's saying, like use this image as reference, just unpackage everything, do the changes whatever we need, and he's just trying to test that image. So how that is, we have to do, Preethi? Like, can we do that? Taking a image as reference and unpacking it, and again do the changes and test the image.
Why do you have to unpack the image?
Um,
Test the image right away by running as a
no,
container.
we haven't. We have to do the changes, right? So already that is an existing image for that service. We have to do the changes and we have to test.
What changes you have to make?
Actually, there were some cache related things and some other changes we are planning. Uh, uh, some cache related things and some configurations we are planning to do the changes. So he has given the existing image. I need to use
And
that
you
image.
don't have a Dockerfile for that image?
No, that's what. If we unpack this image, we'll get all the files, right, from that image.
No.
Docker file, no, right?
Dockerfile you will not get. They haven't given you Dockerfile. Now you have to use the existing image and you have to develop on top of it, right?
Yes, yes, exactly. Yes. Okay.
The best thing you can do is you can pull the image and create a container from it, right?
Mm,
Using Docker run and see what are all the variables you have to pass and start a container. If you can successfully start a container and get inside the container,
mm,
then you can make modifications whatever you want. Like let's say you want to install some thing or configure some cache in some parts and whatever. We have done that also in the class if you see. We have launched a container from Ubuntu. On top of it, we installed it and committed that container. Do you remember that?
yes, a Vim package we have installed.
You have committed the container. Similarly,
Yes.
you can launch a container from it, go inside that, do configurations, whatever you want, and again commit a container, commit an image, and
Mm,
again push that image, separate a new image into your ECR. And again pull it for your test purpose. That's how you can test it. That's one way you can do because you don't have a Docker file, right?
mm,
That's
okay.
one way. Another way is you will not get Dockerfile when you unpack it. No, you will not get it. What you can do is another way. If you can get the Dockerfile from the client, if they can share you the Dockerfile, what you can do is you can add new instructions on the Dockerfile, build a new image, test it. Anyhow, even though the method I told you, like commit a container and push it, you can use it for your testing as well. Right, that's one way. Another way is once you create a container in the commit method, you can inspect that. You will see all the layers added there. From that, from scratch, you can develop the Docker file with reference in that, but you will not get a straight away Docker file. With that reference, you can create your Docker file.
Okay. Okay.
Let me show you what I am saying. Just a second.
Ma'am, related to this discussion that just took place, I remembered one point. And I don't remember. Have we gone through, or is it in that like Dockerizing an application is
Sorry, have we
Dockerizing an application? Have we done that?
in the course?
Yes.
You tell me, have you done that or not? I
No,
want.
means I what I see is that we have pulled
Just a
images.
second, just a second. Okay, let me finish this, what I'm trying to show to him. Okay,
Sure,
and
sure, sure.
have the conversation. So, coming up, what I'm saying is you can start a container, right? Let's say you got this image, you pull this image from your ECR, right? I think you know what I'm saying. I'm just showing you.
Yeah, I understood the concept. Yeah.
Yeah. So, uh, I might have done exit. Okay, just go inside the container, do the configurations, commit that and push it back to ECR. Okay, that's one way.
Hmm.
Another way, what I'm saying is inspect your image. You will see, sorry, history, actually history, not inspect. History.
History layers, we'll see what are all the
Ah,
layers that.
that's where you get a reference of this will give you a reference of what are all the layers there in the image. From this as a reference, you may create your Dockerfile from scratch. That's one way you can do. If client is not providing you the Dockerfile, this is one way. First, inspect that image, pull the image, inspect, try to write your own Dockerfile by seeing this and develop the Dockerfile yourself and add other new instructions what you want. But committing the container is the best way so that you make sure you know you are placing what you want. Commit the
uh,
container, build an image. Then inspect it that one. Then you can also prepare a Docker file from there.
because committing is a good approach. Why? Because Preeti, like we are going to use already a few configurations we are going to use anyway. The
Mhm.
existing configurations we are going to use. We need some of the existing configurations also. But just on top of that, we need to add new one. So in that way, like this committing is good approach, right? Uh,
That's good and perfectly it will work. But the thing why I'm saying is you create that way. But later on, always in the reality, as a best practice, you need to have Dockerfile for your image. Next
yes.
time when you want, or if you want to see what are all present here, Dockerfile is the single source of truth. Every image should have it. If client is not providing, at least for your usage, you should have it. So even though image is developed that way, try to do reverse engineering. Like from the layers, build up your Dockerfile, again build a fresh image from it and test it. If it is working as expected, like you commit, that would be the best approach. Because later on, generally, whenever you make some changes to Dockerfile, it's expected to build a new image, you deploy it and store. That's how it works, right? So always
Yes.
then, so that's why I'm asking you to do some reverse engineering, have this single source of truth also.
Okay, got it, Preeti. And also, we have the client has shared the existing the Groovy script, the Jenkins Groovy script. So that also we need to modify, Preeti. Once we do this image and build everything, so based on these image and the container, we have to do the changes for these Jenkins Groovy script also, right? To make it automate using
That
CI/CD.
is not there. If the Docker image deployment is not there, you have to. What is inside that image, I don't know, right? If it is not there, yes, you have to.
Okay. Anyway, finally we'll do it using CI/CD only.
Hmm.
We got the Groovy script from
Then your
the
Docker file should be handling it.
handling it. Yeah, got it. Okay, we are using these Azure platform is Azure, and we are using these version control is like Bitbucket.
Okay.
Okay, thanks, Preeti. If anything, if I faced any issues or blockers, just
I
help me
think
on
you
this.
can relate to your scenarios in your project, right? With what we are learning here.
Yes, that's what. After once I got these requirement, I had a lot of. I feel very flexible actually to take this. Then I thought to take this task. So any issues or blockers, I'll let you know. Preeti, help me on this if anything required. Uh,
Hmm. Okay.
yeah. Thanks, Preeti. Thank you.
Yes, Rishi, now please go on. You are saying you are asking, have we done Dockerized or what is your question? Please go on.
Yeah. So actually, what we have seen, uh, we have built an application which was a Java-based application. So that's why we used Maven and everything. And we built that application and we deployed it. So I mean, I'm not aware, but I've heard this concept is that Dockerizing a particular application means preparing. So it can be any application, preparing it to be able to run as a Docker container.
We have covered this, Rishi. Yes, Dockerizing, containerizing, this concept is covered thoroughly in the Docker part. Just go and revisit there. Yes, we have covered it.
Okay, because its terminology is only different. We saw an application building, so it is the same thing, right?
Not application building. Application, containerizing your application is different from building an application. Writing a Docker file and creating container from it is containerization or Dockerizing.
Right, but I mean, the image that we receive from Docker, from the Docker Hub right now, which are ready images, right? And those are called Docker images. What I mean to ask is like, how can we create our own application if we need? Have we covered that part? Own application. It can be a Linux application or it can be a maybe.
Why would we create applications? DevOps team will not create applications. You will get applications from developers and you'll containerize it into a
Okay,
Docker image.
okay. Okay. So only deploying is our means images will get ready. Okay, fine. But uh, the superficial question about it is that Dockerizing an application is a different thing and containerization is a different thing.
Both are same. Both are same.
Okay, and I mean, and we have covered that topic as you said, right?
Yes.
Okay, okay. Just the words were different, so I could not understand because I
I
don't know
mentioned the
exactly.
Dockerizing also, Rishi. Just go through the recordings, okay? See,
Okay,
I'm requesting everyone watch the recordings every day before you join the next class so that it will help you to understand and cope up with the content we are discussing. Please watch the recordings. I definitely know, I definitely understand. These are all new things. It will take some time for you. But to understand what topics are covered, at least what is happening, please watch the recording so that you will not have confusion after the end of the class. Like you should know whether the particular topic is at least covered or not. Yes, Guru, any question? Please go on.
Yeah, this is very basic question, Preeti. So I saw some config.environments in some of the uh, Jenkins files.
Mhm.
So where do we define that config environments?
Which config environments, Guru?
I just saw the variable declared at config.env, and I'm not able to get those paths actually.
I have to see the file so that I can tell from where. Without seeing that, I can't tell from where this is coming. Let me know or show me like where it is called and how it is called so that I can help you.
Yeah, Preeti, I will
Need
ping
to
you.
have a look at it, right?
Yes,
Without
yes,
looking
got
at
it,
it.
got it. Yeah, that's what I
If
mean.
you
I
have
just
any snippet or if you have the snippet references, do share it with me. Maybe we have to get into the environment to see where they were actually. So try to share whatever you can so that I can help you.
yeah, sure.
All right, then thanks everyone. See you tomorrow. Bye. Everyone.